Welcome to Tech Talks. Tech Talks is a series of short webinars that are deep dives for technical practitioners. Our Splunk experts help create these best practices in hopes that you can leverage them in your day-to-day activities. We value you as a customer and want to help you continue on your Splunk journey. Today, our IT edition is focused on the convergence of observability and IT teams. Allow me to introduce our presenters for today. These guys are fantastic. Nick is a consulting sales engineer manager based out of Arizona, and Jan is a sales engineering manager based out of San Francisco. Both of these guys live and breathe our IT and observability products and truly represent the voice of our customers. I'm so excited to have them here today and to show you how our products work together to reduce MTTD, MTTR, and help prevent revenue loss in today's example. Today's presentation is going to cover our Better Together products and solutions, a high-level story, and then we're going to go into a demo of the relationship between IT and observability roles. Finally, we'll do a quick cover of additional resources available. And just a note here, our team will be available for Q&A throughout over in the Q&A widget within your screen. And if you watch a recorded version of this webinar, please continue the conversation through the Tech Talk discussions in the Splunk community at splunk.com/techtalk.
Hello, everybody. My name is Nick McCroglu. I am a consulting sales engineering manager here with Splunk. And on the line with me today, I have Jan Yu, a senior sales engineer specializing in our observability portfolio. We're going to be walking you through our Better Together messaging, which is the story of central IT and SRE teams working together in tandem. Let's go ahead and jump into the demo. Okay, looks like I just received an incident on my mobile device. Let's go ahead and drill into that incident. So it looks like VictorOps is saying that we have an alert for our online revenue service. This is definitely business facing, and I need to jump on this right now. I'm going to go ahead and acknowledge this alert. And I'm going to look at some of the alert detailing that I have in here currently. And I can see that this is coming from our production system. Yep, this is definitely revenue facing. Okay, I'm going to go ahead and switch over to my, my internet browser really quickly. Okay, perfect. 1893. Let's go ahead and look at some of the annotations that I have here. So I can see that within the alert annotations, IT Service Intelligence has delivered via the notable event that brought me to VictorOps that I have a link to our online revenue overview, which is a glass table that we have purpose built for our CFO and CTOs. So let's go ahead and drill into that. Okay, yeah, we are definitely hemorrhaging money. We are in an outage state. It looks like there's a slew of 500s that just came onto the system, and we're losing some cart value here. Some of our shoppers aren't happy right now. I need to really jump onto this and investigate. Let's go ahead and drill into that. So I can see that this brought me into our service analyzer and our IT Service Intelligence platform. And this brought me specifically into our online and revenue payment systems. And I can see that we are hemorrhaging money across our gold and our platinum environments. Okay, I can see the entire storefront is affected. I can see that both our mobile and our web front ends are being impacted. And this is stemming all the way down from our API service. Let's go ahead and follow the direction of the error. Our API service is showing an error request percentage increase that seems to be stemming from our checkout service. Now, these metrics that we are looking at here are coming from our newly acquired capability with SignalFX. And we are leveraging the Smart Agent to then start pulling in some of these detailing to then give us some additional KPIs around rate, error, and duration. So I can also see that our checkout service is being affected by this with an error percent increase of about 17.3%. And I can see that that's directly connected to our payment system. But I also noticed that checkout is connected to our cloud database service, which we have recently refactored to run into the cloud. So let's go ahead and drill into that first, because we do have some databases here that are definitely dependent upon the success of Buttercup Online. Okay, I can definitely see that we have some memory utilization errors going on here. And this is also coming from some of our infrastructure monitoring that we are leveraging with SignalFX in our cloud native environments. So drilling into that, I can see that two of our Kubernetes nodes, node 11 and node 12, specifically are an alarm for some memory pressure that we are seeing across both of these nodes. That's super interesting to me, but there really is no direct correlation to the payment service. So considering we are losing money right now and we are in an outage state, I'm going to go ahead and drill into this payment service, and I want to see what's going on here. And I noticed that the payment service has the highest percentage of error request percent across its interface than all of both my API and my checkout service. So this seems to be might be where the problem is actually centrally located. But I also noticed that we have a memory percentage increase here, specifically on Buttercup Game node 6. So this is actually super concerning to me too. We have two separate services that are not directly linked to one another, but we are receiving some memory pressure across a couple of the Kubernetes nodes that are in this pool here. So I'm going to want to go ahead and drill into some of these notable events that IT Service Intelligence has aggregated here specifically for the payment service, and see what they the detailing around those notables are. So leveraging the capabilities of episode review and event analytics within IT Service Intelligence, and some of the noise reduction that we can gain from this platform, these are the most concerning alerts that are directly related to the payment system. So I'm going to go ahead and, as part of these are definitely impacted entities here as part of this incident. I'm going to go ahead and actually take an additional action here as part of this new integration that we have with our observability platform, and explore the detailing of this within SignalFX, specifically looking at some of the infrastructure related metrics that I can then start to understand what's going on. Now, also, I'm going to go ahead and pop over to my mobile device one last time, and I'm going to go ahead and actually add my SRE on call right now to the alert, and he's actually going to jump on the war room with me and start triaging this with me in real time. Awesome. So Jan has just been paged. She should jump on here any second.
Hey, Nick, how's it going?
Hey, Jan, it's going great, man. So you remember Red Tuesday, the outage that we had about 2 months ago?
Oh, yeah, how could I forget that?
Yeah, it's been seared into our memories forever. So due to data transparency, I had an alert that just got kicked off to me, and this was a revenue impacting event. Reviewing this in our service analyzer in IT Service Intelligence, basically I followed the trail of the alert all the way back to our Kubernetes Navigator, where I'm seeing memory pressure specifically across host node 11, node 12, and node 6. And I'm not quite sure what the correlation between either of these are from a dependency level, but I definitely know that both of these services are being impacted by this right now. Do you think you have a second to walk through this with me?
Yeah, let's do it. I'd noticed this I've seen some of the alerts flying by, so I was kind of looking into this myself. You're right. I think there's something going on in our Buttercup Games environment. And so what we have here is we've got our Kubernetes Navigator showing us 12 different nodes in this environment. Each of these nodes has anywhere from 2 to 4 pods within it. And as we can see, SignalFX has identified that 6 of these nodes here are under a memory pressure condition, indicating that they have some sort of too much memory usage for the memory that they have, right? So one of the things I want to do, for example, one of the things I can do here is to zoom into one of the nodes to get a sense of what's going on there, right? So here what I can see is I can see that, there's the Buttercup Games node 6. I can see that there's an Autobot workload, a payment workload, SignalFX agent workload, And actually, what I really want to look at is specifically my payment services, because I think that's what's been having some problems here, right?
Yeah, I definitely could confirm that.
And so here on this payment service, what I'm saying, this is the pod Buttercup Games Payment 4. You can see the workload type, see the payment workload here under the commerce. See the CPU usage here seems fine. Memory usage here seems fine. Nothing indicates to me that there's a problem with my payment service, which is weird because I know that a lot of my payments are starting to fail right now. I can dig a level deeper here by drilling into the container within the payment service as well. And so here I can see the name, the pod, the image that we're using, and you see here that the memory limit, CPU limit, and the utilization. Nothing here indicates to me that there's a problem with the payment service, and yet we're failing payments.
Yeah, and you know, I don't know from here, where do we go? How would you go one level further? If it's not this payment system, what would be another step we would take from here, Jan?
Let's go back to that node level view again, right? So maybe I went too fast here. So we can see the Autobot, we can see the payment, we can see the SignalFX agent running. We see the CPU usage overall on the node seems pretty light, right, in the realm percentage points. But here's something that's interesting. We've got 90% CPU memory usage by one pod in particular. So it looks like the Buttercup Games payment services are down here, and we've got the Buttercup Games robot running at 90% of memory usage for the node. That's kind of alarming.
Yeah, that's super interesting to me. What is this robot pod? I'm learning SignalFX, but that pod doesn't really look natural to me. It seems new. It doesn't
let's look
seem like
into it.
Yeah.
So if we dig into the pod here, we get some of that same data, right? So we can see the pod network throughput, the pod network errors. We see again, we're confirming that this one pod is taking up 7 gigabytes of memory, which is not great. But there's nothing in here that indicates why that would be. So let's go one level deeper into the container again. And here we can see that, it's the key image robot, CPU memory usage, CPU limit. And it looks like this may be the problem here. It looks like somebody might have dropped this into prod without checking the memory limits on this node, which is not great.
Okay, let me, you know what, I'm actually, while we were talking about this, I pulled up our maintenance schedule, and it looks like our app dev team was doing some testing for an upcoming release that they have in the next few weeks, and this might be directly tied to that. Let me go ahead and ping the engineer on this. Hey, Sam, did you deploy something just now? Yeah, he said yes. Okay, I asked him about the memory setting. He literally just sent me the facepalm emoji. Okay, yeah, he's rolling this. He's rolling this back right now. Yeah, he's okay. Yeah, he said it should be remediated. We should see evidence of that here, right, Jan?
Yeah. So SignalFX is having metrics pushed to it by the Kubernetes cluster every 10 seconds or so. So we should be able to see this resolve itself within a few cycles here. And one of the things that we can verify here as well, actually it looks like there it goes, right? So the memory pressure condition has been removed from these nodes. So these nodes are now back on regular memory usage. We don't think that there's any problems there. And if what he did was to go ahead and remove those containers, the robot containers, then we should also see those get removed from the view here as well. And you can see those winking out of existence here, all the Buttercup Games robot nodes that we're running. So it looks like that should have solved the problem.
I wonder how much money that cost us this time, because I know, due to Red Tuesday and data transparency here at Buttercup Online, like I have a really cool dashboard that I could show you.
I do too. I don't think you've seen this one yet, have you?
What? Where did you get this?
So after that last incident, and after we announced the data transparency stuff, I went ahead and grabbed one of your engineers, and during our last hack day, I wanted to pull all that data back into our infrastructure monitoring tool, so we could correlate the revenue directly with Kubernetes and all the infrastructure metrics we have.
So that you guys could be aware too if things were happening in your org or across platform. This is perfect. This is exactly what we were looking for data transparency. So 427, that's nothing to what we experienced for Red Tuesday. We are getting better here. So let me Let me ask you this question, Jan. In trying to beat that number next time, is there a way that we could set a detector specifically for that memory setting? Because I know, as we move faster to refactor and deploy into the cloud, some of these things are going to happen again. We're going to make some errors. Is there a way that we could create a detector that's smart enough for us to get it engaged when somebody makes a mistake like this moving forward, or something went unchecked, or any one of those conditions?
Yeah, absolutely. So what we can do is we can jump over to our infrastructure view here and take a look at all the Kubernetes containers that are running. Within this view here, we'll see about 2,000-ish Kubernetes containers, and we see that some of them are kind of varying colors depending on how utilized they are. So what I would want to do, given what you're saying, is let's set an alert on memory usage, right? So what we can do is we can click here and create a new detector from chart on memory usage. And what this will allow me to do is to specify that I want to look at container memory usage in bytes across all my Kubernetes clusters. And then I can specify an alert condition. And in this case, let's do something relatively simple for now until we can get back and maybe make this a little more dynamic. But what we can do is we can say, if any container goes above, say, 7 gigabytes of memory usage, that's too much. That's something we need to be alerted on right away, right? And so what this will do is this will go ahead and backtest this alert against the past. Let's go ahead and just give you the last 1 hour of data. And it'll tell us how many times it would have fired off. And here what it's telling me is this would have fired off maybe about 18 times, including the 6 containers that we saw that triggered this entire event here around, 20 minutes ago now?
Wait, I actually literally had to pick my jaw off the floor here, because what you just showed me was very eye-opening. So you mean to tell me that you just could test this alert across almost 3,000 containers and confidently say that this is when this would have triggered, and then this is when this would have cleared, before I actually applied this to production?
Yeah, that's right. How else do you manage these giant container clusters?
Long nights, long weekends, long walks on the beach to clear my mind. I mean, you name it, Jan. I have been down that road, but this seems to be super beneficial. I think we can get really smart on some of our alerting going forward with this capability. What are some of the other ones in there too? I saw that there were some other settings, because I like the static one, but I think, there might be a little bit of a condition where that might not apply here. So what are other, walk me through some of this stuff too.
Yeah, so we can, in addition to static thresholds, right, for periods of time, we can also do heartbeat checks where we tell you if a signal stops reporting. We can do resource running out, which is useful in these cases as well. It's predictive. It'll tell you when a resource is going to, or a metric is approaching some capacity or some zero number, and it'll alert you, a day, a week, a month in advance. We can also do outlier detection. That's really helpful for, a load balanced set of nodes to let you know if one of them is acting differently than the others. We can also do set and change, which will take the past, say, hours worth of performance and compare that to the last 10 minutes to let you know if a metric is suddenly changing up or down. And we can also do historical anomaly, which will compare, performance for the last 10 minutes, that same time period a week ago or a month ago or multiple weeks ago. So I think we definitely want to go and try one of these out eventually, but what we want to do is to make sure that we're picking the right tool for the job, as it were.
Absolutely. I think maybe we should schedule some time with the app dev team, maybe next week, to go through some of those alert conditions and see what would be beneficial for them and their needs. So, Jan, it looks like I'm not aware if you've actually seen some of the work that we've been doing with your team on the Better Together stuff. So here actually are some of the work that we've been doing with your team to map in these red metrics for rate, error, and duration. Specifically, yeah. And it looks like the service analyzer has cleaned up quite nicely. So yeah, you can see that everything has cleared up from the Cloud DB perspective. All of the disk spaces returned to normal, as we saw on the Kubernetes Navigator menu. Payment seems to be better. Checkout seems to be better. We don't have any more error percentage increase. Seems to be okay here. And And it looks like we stopped hemorrhaging money here too. So that lost revenue actually has stopped. So I think we definitely has, I think we found and solved the issue here. So I'm going to go ahead and acknowledge the alert and actually resolve this. And that was what, about 21 minutes. That's not so bad. And actually, so next week I will set up some time with you and the app dev team, and we'll go ahead and go through those alerts. But again, Jan, I can't thank you enough for jumping on. I think we really avoided a catastrophe here. So I hope you have a great day, man.
Anytime, Nick. Glad I could help.
Okay, we're about ready to wrap up this tech talk, but before we do, I wanted to share the resources available to you to continue your journey. You will receive these assets in a follow-up email as well as the recording. So here we have our complexity jerk obscurity video, which is hilarious. I highly advise you watch that. Then a guide to AI ops, and then another guide that's 12 immutable rules for observability. And last but certainly not least, a free trial of Splunk Observability Cloud, and there is the link. A friendly reminder here, don't forget that we have an incredible community of Splunk users on our community site. You can search and share best practices on Splunk answers. You can even continue the conversation for this talk within the discussion section called Tech Talks, where you will find all the additional resources as listed on the previous slide. And finally, there's Splunk Ideas, where you can submit a new product enhancement or vote for current ideas from other customers. Phew, all right, head over to these pages rather than listening to me struggle throughout remembering all of them. Most of all, thank you. Thank you to our presenters today, and especially to you, the listener. We really appreciate you taking the time out of your schedules to join us today. Please tune back in for future Tech Talks. We're really excited to share this series with you.